So, good afternoon to all of you. Thank you for your presence in this third webinar within the GLOW-URB project financed by the National Research Agency and also co-financed by the Lyon University, which is H2O Lyon Research Institution and the Urban Water Project. So this webinar fits within the framework of the Water Week organized with the H2O Lyon. So third webinar after two webinars which took place, which discussed with issues, global issues um, such as anthropic pressures and on hydrological systems. Today we will focus on the on sediment mining and associated with urban sprawl. And we got case studies from different sites of the world, from Bolivia, India, Chile, France, and also in French Guiana. So with no further ado, I will give the floor to Luis Hernandez to deliver the presentation dealing with modeling the functioning of the aquifer in the largest urban center of the Altiplano in Bolivia and the potential role of extractive activities. And Luis, you have the floor.
Merci, bonjour à tous et à toutes.
Good
Bonjour de
afternoon.
ma part.
Hello.
Je m'appelle Luis Hernandez et je vais vous
My name is
présenter
Luis Hernandez, and I will
un petit
talk
peu
about
des travaux qui ont été menés
the
dans le
work
cadre de ma thèse.
we've carried
J'ai
out
reçu des
within
recherches
the
scientifiques au sein
for
de
my
l'Institut des
PhD
sciences de
with
l'environnement de
Céline
l'Université Grenoble.
Duwig
Donc,
for
la
the
modélisation
Grenoble
du
Alpes
fonctionnement de
University
l'aquifère le
Center,
plus grand du
the
centre urbain
modeling of the function of the
de
aquifer,
l'Altiplano
the
et d'évaluer le
largest in the
potentiel des
urban center
activités ou de
of the
l'activité
Altiplano,
extractive.
Bolivia, and the
Tout
potential
d'abord, je
role of
vais donner
extractive
un petit peu de
activities.
contexte,
First, well, I'll give you the
mon
context,
étude, quelques
the
caractéristiques et les questions
methodology,
scientifiques. Ensuite, je
characteristics,
vais
results,
parler des méthodes, méthodologies
and the
qu'on a implémentées
and
pour
the
donner
methodology
réponse à vos
which
questions.
is used
Tout de suite,
to answer the
quels sont les
questions, and
résultats
then
principaux qui
I
nous
will show
intéressent
the main
dans cette webinaire.
results,
Et
which are
finalement,
of
je donne mes
interest for
conclusions
us in
et
this webinar.
perspectives.
And at the end, I will give you conclusions and
Donc, le
perspectives.
domaine d'étude se situe, c'est l'aquifère du
So
centre
this
percé du Qatari et lac Melun
I've
qui
studied
se
the
situe
aquifer in the
sur l'altiplan
Qatari
boliviano
and the Minor Lake, which is
au
in the
sud-est
Altiplano of Bolivia,
du lac
and the
Titicaca, à l'ouest
southeast
de la
of
cordillère Mayenne,
the
par exemple.
Titicaca Lake on the
C'est
east
bassin
of the
a une superficie d'environ
Cordillera.
2500
So
km,
the
qui
aquifer
présente
covers about
trois
2,500
semi-arides.
kilometers. It's
Les
a cold
précipitations qui varient
semi-arid
entre
climate. Rainfalls range
577
between
et 750 mm par an
570
du
and
côté de la
750
Dordogne
millimeter
et
per year on
800
the
mm
mountainside
par an
and
du
800
côté du
millimeter per
lac,
year
avec une
on the lake
évapotranspiration qui
side.
varie entre
And the evapotranspiration
1160
ranges between
mm par an du côté de la cordillère
1,200 and
et
1,700
1700
millimeter per
mm par an du
year.
côté
And
du lac.
on the Cordillera, on the
Les villes
mountainside and on the lake
principales sont
side.
El
The main
Alto, Viacha,
cities
Tucarani,
so El
Petén,
Alto,
El Alto,
Riaca,
la
and
ville la
Pucarani.
plus peuplée
And
de l'Altiplano. Environ le 9%
El
de la
Alto has
population
the largest
bolivienne.
population, that is 9% of the
Donc,
Bolivian
les
population.
problématiques dans les bassins
Now,
versants, des problématiques
water
de l'eau.
issues
Tout
in this
d'abord, on peut
catchment
repérer
basin.
la disparition du
First,
glacier de
there is the
Chacaltaya, un
disappearance of the
bassin naturel
Chacaltaya
précieux.
glacier, disappeared in
Et il faut dire que
1988,
dans le bassin
and
versant, l'approvisionnement en eau potable
in the
vient
catchment basin, the water supply,
principalement de
drinking water
surface.
supply comes from
Et il y
the
a eu des
surface
problèmes
water.
qu'on peut citer plus précis
There's
en
been
2012, par exemple,
problems,
des
more
problèmes
precise, in
tensionnels résultant de la
2012, for
croissance
example,
urbaine
a
rapide de
problem
l'Alto.
that
Donc, ça a
resulted from
entraîné
the
une crise de
fast
périmètre.
urban growth of the El Alto,
Ensuite,
which led to
en
water
2016,
shortages. Then
2017,
in 2016,
avec des faibles
17, there
précipitations ou
were
mauvaises
very
précipitations,
low
ça entraîne aussi
rainfall
des
and poor
problèmes de
anticipation.
crise les
There
plus
were
longs de
also
l'histoire,
a
en
problem,
fait.
the longest crisis
Et
actually
ça, c'est en termes
ever
de
in that
quantité.
country.
En termes de
And then
qualité,
And in terms of, that's for quantity. In terms of quality,
juste pour citer, Arthundi en 2016
well,
a trouvé, ils ont
in
trouvé des pollutions
2016,
dans ces canaux
it was found
phygéliques,
that there were pollutions
sulfamétoxazole, avec des
of
concentrations
antibiotics,
qui varient entre 11
sulfamethoxazole,
et 1300
concentration
nanogrammes
ranging
per
from
litre.
11 to
Ça, c'est en
1,300
surface,
nanograms per
mais
liter.
dans les eaux
That's for the
souterraines et sous
surface.
moindre mesure,
But
ils ont
in the
trouvé
underground
aussi
water, they
sulfamétoxazole
found also
entre 48
the
et
same
272
substance between 48 and
nanogrammes par litre.
272 nanograms
Il
per
faut mentionner
liter.
que donc, ces
In So
sulfamétoxazoles,
this
c'est un
is a
potentiel
tracer
d'activité
of
humaine.
human activity.
Toutes ces situations de quantité et de qualité
This situation,
ensemble
in terms of quality
a
and
obligé la
quantity
population les premières
combined,
décisions
led the
de dépendre de
population
plus en plus des eaux souterraines.
to
C'est pour ça
depend more
qu'ils ont commencé
on
à faire des forages,
underground
mais
water.
on se pose la
That's why
question,
they started doing
est-ce qu'il y aura
drillings
de
and bore.
l'eau?
But
Quel est
will there
l'intérêt?
be
Le
water?
problème, ça
What's
nous
the
pose,
quality of that
ça nous
water?
a
So they
motivé à faire
started,
à
and also we
présenter
wanted to
aux services
examine
scientifiques comment
the,
fonctionne
well,
l'aquifère et où va
the
la pollution.
functioning, the operation of the aquifer, and
Donc, la
where
méthodologie
does
pour
pollution go?
répondre
So the
à cette
methodology. So
question,
we,
tout
to
d'abord,
understand
pour le
this,
fonctionnement de l'aquifère, on
first,
parle on
for the
servi
operation
d'un
of the
modèle,
aquifer,
d'un outil de
we
modélisation. Cette
started a
modélisation
modeling
à
tool.
base physique, tout d'abord, on a
Is a physical
développé un modèle
modeling
Boolean
system.
avec
We
lequel
developed
on estime, on calcule
a
un champ de
flow
vitesse, un
model.
champ de
We
charge hydraulique et
studied
avec
the
lequel on
the hydraulic
peut
head, the
déterminer les
velocity
systèmes
head,
d'écoulement.
velocity field, sorry, the hydraulic,
Ensuite,
the head and the
un
field,
modèle de
and
temps
the
de transfert
velocity
qui va
field, and then
complémenter
we can
l'écoulement
study
et qui
the
nous permet de
flow
savoir
system. Then
le
we have
temps
a
qu'il met
transfer
une
time
molécule d'eau
model.
depuis l'entrée
We
jusqu'au
can
récepteur.
see how long it time
Et
for
aussi, on
water
a
to get to the
développé un
aquifer,
modèle de
and then
probabilité de
we
sortie
developed
qui nous donne un
a
champ de probabilité,
discharge
c'est-à-dire la
probability
probabilité
model, which
de
gives us a
l'eau souterraine
probability field.
de sortir
That is the
par un
probability
extracteur.
of
Ça nous
underground
aidera
water
à
to
affiner
go
les
through
systèmes
an
d'écoulement.
outfall or a spring or whatever.
En
So,
sachant, après
bearing
avoir
in mind,
étudié
having
le fonctionnement
studied the
en termes
operation
hydrauliques, donc
in terms of
on peut
hydraulics,
essayer d'évaluer la
we
pression,
then
l'impact de la
try
pression
to
anthropique.
assess
Et pour
the
ça, on a développé
the
un modèle de
anthropic
transport de
pressure,
soluté.
and we developed
Ce
a
modèle de
solute
soluté
transport model,
prend en compte
which
trois scénarios de pollution
takes into
potentielle.
account
Les
three
foyers non connectés au réseau
potential
d'égout. C'est ça que
potential
ces foyers ils
pollution
vont
scenarios. So,
jeter directement les eaux
non-connected
usées
household, which are not connected to the
sur les sols,
the
qui va
sewage,
arriver
so they
à l'aquifère.
discharge
Les
their
centres d'enfouissement des déchets
wastewater on the
et
ground.
les
They will
rivières.
go to the
Et après, je vais vous
aquifer,
expliquer pourquoi
the
les rivières. On a pris les
landfills
rivières.
and
Et les
rivers.
cibles,
And I'll
les
tell you
cibles
why we took the
possibles où
rivers.
on
And
va
then
évaluer
the possible targets
l'impact, c'est
will
les fonds
the,
captants de
to
l'Alto,
assess impact, well,
qui sont humides, les
the
rivières et les
catchment
sorties d'eau
basin
vers
of
la
Del
base
Alto,
algebraïque. En fait,
wetlands, rivers,
en
and
termes
the
pour
water
être plus pratique,
discharge
je vais vous
towards La Paz
présenter
and Achocala. So I will
les
present
scénarios des rivières et les cibles qui
the
sont
river
toutes les rivières.
scenario and the catchment
Donc, les
basin
résultats.
of El Alto
Lorsqu'on
and
parle
the
de
river. So
fonctionnement de
the
l'aquifère,
result, we talked
il
about the
faut
operation of the
penser
aquifer. Well,
faire
think
une
about,
discrimination de trois composantes.
we have to
La
make a
nature de la
difference between
décharge,
three
la
components.
distribution des systèmes
First, the
d'écoulement
nature
et
of
le
the
temps de transfert.
refill of the recharge,
Tout
the
d'abord,
distribution of the
la
flowing
nature de la
system,
décharge.
and
Trois
so
conditions limites
nature
permettent de
of the
tester le fonctionnement de la
refill,
décharge,
so
c'est-à-dire
or
que la
recharge. So
décharge, dans le
first,
domaine d'étude,
three limit conditions.
est
What would be
composée
the recharge in the domain?
d'apport des
There will
glaciers,
be,
c'est-à-dire la fonte
well,
des glaciers,
contribution from the glaciers.
infiltration
There is
efficace,
a
c'est
melting
un
of
apport de
glaciers,
pluie et les
efficient
échanges entre rivières.
infiltration from rainfall, and of course, exchange
Donc,
between
avec les meilleurs résultats
the river and
de la
the
simulation
aquifer.
avec
So,
ces
with the
hypothèses
best
testées,
result of the
nous
simulation
avons
and with the
trouvé
tested
que
hypothesis, we found
les rivières sont
that
le point
rivers
le plus important dans les domaines d'études,
are
avec
the highest
86%.
contributor to the aquifer,
On a
with
trouvé
almost
aussi que les lacs,
86% of the inflow.
et
The lake as
malgré
well,
qu'on a nous avons toujours
despite the
cru
fact
que
that we
c'était
always
l'aquifère qui
thought
alimentait les lacs,
that
mais
the
nous nous sommes
aquifer
rendu
would
compte que c'est
feed the
aussi
lake, but in fact,
qui
the
alimente
lake
l'aquifère. Donc,
in
c'est ça
some
un
domain will
message
actually
important
feed
à donner.
the aquifer
Ensuite,
or the
les systèmes
underground water
d'écoulement.
table. And
Donc,
then
à gauche,
the flow system.
Je
So
vous
the flow
présente
system,
la
you can
distribution des
see
systèmes
on the
d'écoulement. On
left-hand
peut
side
remarquer que
the distribution of the flow system,
c'est assez
and you
complexe
can
de
see that
distribution. On a des systèmes de
it's
taille
rather complex
locale,
in terms of
de taille
distribution.
intermédiaire et de taille
There is the
régionale.
local, intermediate, and regional
Donc,
size.
ce qu'on a fait, en sachant
What
qu'il
we
y a,
did,
c'est
but
difficile de faire
it is difficult
une analyse avec cette distribution
to
assez
do an
hétérogène.
analysis
Nous
with
avons
this
fait
rather
une simplification
heterogeneous distribution. Therefore, we
et
did a
après, on
simplification
a déterminé 100 systèmes d'écoulement. Les systèmes
and
du
we
côté
find
les systèmes
five
du lac, les
systems:
systèmes
the mountain, the
des
lake,
Qataris
and
et les systèmes du sud. Et les
the
systèmes les
Qatari,
plus importants qui se trouvent dans le
and the
secteur
largest
de
system
l'Alto, c'est le
found
système de
in
Duwig.
the Ento,
Il faut
the
mentionner
wells.
que lorsqu'on parle de système d'écoulement, la
We should
définition,
mention
c'est
that
une
we
zone
talk about a
de
flow
recharge
system
liée à un
that
excitant
is a
par des leviers.
recharge
Ça, c'est
zone
notre
associated with
unité
an outfall
hydro-géomorphique
through a
d'analyse.
linear system. So this is the system for the
Ici
analysis.
à droite, je vous présente donc
On the
la
right-hand
manière
side,
comment on
you can
a
see
raffiné le système d'écoulement
we
avec les chiffres
refine the
qui a été formé
analysis
par
of
l'équipe.
the
Ça, c'est
flow
l'excitant.
system formed
Donc,
by
avec
you
les
see the
modèles
outfall here,
d'excitabilité.
and so the wells with a probabilistic model.
On a défini donc
Then
les
we
systèmes
defined
d'écoulement. Il faut savoir combien
the
de
flow
temps
system. Bear in
une
mind
molécule va
that how
prendre
long we have
d'aller
to know
depuis
how
l'entrée
long it
du
takes
système
for
jusqu'à
the
l'excitoire.
water to
Avec
go
notre
from the
modèle de temps
entry
parfait, on
into
a
the
déterminé
system
que le
with
temps
the
total
groundwater, the table.
depuis l'entrée
So the
jusqu'à
time
l'excitoire ne dépasse pas les 55 ans.
from the
Dans ces
entry to
secteurs
the
proches à la
outfall,
rivière.
it does not exceed
Mais vous pouvez
55
remarquer
years
aussi
close to
que
the river.
dans
But you can
la
see as
zone
well
lacustre,
that
il faut mentionner qu'ici,
in the
il y a
lake
la zone lacustre,
zone,
la zone
you
de
here
Piémont.
there is
Et dans
the
cette
log
zone,
zone,
on ne voit
the
pas
Piedmont zone, and we don't see
d'estimation.
any in that
C'est-à-dire
zone. We
que la
don't
période de
see any
modélisation qui a
estimation.
été
That
de
is the
1991 jusqu'à
modeling
2016
system since
ne suffit pas.
95 to 2017, well,
Mais
is not
on sait
sufficient.
déjà que ça
But
dépasse
we know that
les 55
it
ans. Et c'est pour
exceeds
ça qu'on a décidé de
55
faire
years.
une
This is why we
estimation par
decided to
approximation difficile
create
avec la loi de
or
Darcy.
to do a rough
Et
assessment
on
with
a estimé
with the
des temps
Darcy law,
transverses
using
qui peut
Darcy law,
dépasser ou qui
and
peut arriver
we
pour toucher
assessed transfer
des milliers
times
d'années.
that
Donc, ça, c'est
the transfer
important
time
parce que
can take
ça nous
up to
montre qu'il
1,000
y a des
years. So
secteurs
it shows
dans
that
les bassins versants
clearly
où
there are
les eaux souterraines
domains in the
sont
catchment
récentes,
basin where
mais aussi il y
groundwater
a
table
des
are
secteurs
new,
où
but
les
there are
eaux
also
sont très
zones where
anciennes.
the water is
Ça
very, very
aura
old, actually,
des applications
very ancient, like
opérationnelles
10,000
en
years,
termes
up to
aussi de
10, so
qualité, de
that we'll have
quantité, en termes
operational assessment
d'extraction,
in
en
terms of
termes de
quality,
pollution.
quantity,
Et on se
in
rend
terms
compte
of
que dans le
pollution.
secteur de
And
l'Alto,
we realized that
où
in
les temps
the
de transfert
Alto
sont plus
zone,
courts,
where the
en
transfer
fait, c'est
time is
où il y
shorter,
a
in fact,
la
this
pollution
is
assez
where
forte.
we get the
C'est pour ça que
highest
dans les
surface
travaux
pollution.
de
This
cette
is why in the
recherche, on se
work
concentre
of this
sur
research work, we concentrate
ces parties-là, de ces secteurs
on
de
this
l'Alto.
on this
Pour évaluer la
domain
pression
of the
hydrique,
Alto. Now, to assess the anthropic
comme
pressure,
je vous avais mentionné, les cas où les rivières est
I
une
mentioned the
source
case when the
potentielle, c'est à
river
cause de
is a potential source is
lorsque la
because
ville, la tâche urbaine commence
when the city
à
or the
augmenter
urban
et entre en
sprawl
contact avec les rivières,
expands
en
and
sachant que les
comes into
rivières, ils
contact with
sont
rivers, knowing
la
that
porte
rivers
principale de
are
la
the main
recharge de
contributors
l'aquifère, on se rend
to
compte que
the
c'est
recharge
les
of the
rivières qui
aquifer or
peuvent
the
être
table.
une source
And
potentielle
rivers
en
can
étant en
be
contact
a
avec
potential
les zones urbaines.
source,
Et
being
si
in
on se
contact with
situe
urban
dans
zones.
cette
And
dernière
if we now look at
figure, que
this
c'est de 2016, on peut
last figure,
remarquer que le panache de
2016, you can see
pollution
that
avec un
the
modèle
plume of
de
pollution
transport de
with
soluté nous
a
présente
model,
que
with
nous
solute
montre qu'il y a des pollutions qui
transport
peuvent atteindre les puits.
pollutions can
Donc,
reach
ces puits qui
the
sont
wells,
représentées par cette panache
the
et,
wells which
et
are
pour
there,
avoir des
and
impacts importants. Il faut dire
this could have
qu'un
an
modèle à
impact,
transport de
major
soluté
impact there.
prend en compte
With
un peu
solute
loin des
transport
substances
takes
qui
into
ne se
account
dégradent pas, donc ça c'est le cas le pire.
substances
Et
that do
on
not
peut remarquer
degrade,
aussi qu'il
which
y a
are
des
the worst
concentrations qui
one,
peuvent
but there
arriver.
are
On
also
parle ici en
concentration
termes de
which
concentration
we
relative
talk in terms
pourcentage,
of
c'est-à-dire que
relative concentration percentage.
90% du
That
traitement
is
peut
the
arriver, là c'est en
90%
rouge,
of
peut
the
arriver à ce puits.
can can get to the well. So if we
on va
see a
avoir
concentration in
la
rivers,
concentration qui va arriver
we know the concentration that will come to the well.
C'est tout ça juste pour faire une conclusion qui est l'outil de
Okay, one
modélisation.
conclusion, basically, with the
Avec
modeling
notre
tool,
modélisation, nous sommes
we were able
pu
to study the
comprendre le
Qatari
fonctionnement des
groundwater
aquifères de
table
Qatar
operation,
et on a
and
pu
also I
évaluer l'impact de
studied
la
the
pression anthropique
impact
en
of
termes de
the
pollution
anthropic
et avec
pressure in terms of
scénarios
pollution and
que je vous ai présentés.
with the
Les modèles de
scenarios I
courant ont permis
presented.
de tester
The
des
flow
hypothèses
model
sur la
made it
nature de la
possible to
recharge,
test
mais il
several
apparaît que
hypotheses
les
on the
échanges
nature of the
navires sont le
recharge,
phénomène majeur
but
pour le
clearly
recharge.
the
Du fait
table
à la
river exchanges are the major
multiplicité des
element.
systèmes d'écoulement
Due
identifiés,
to
on
the
a effectué une
multiplicity of the
simplification qui a permis
identified
la
flow
détermination
system,
de 5 grands systèmes
we
d'écoulement.
did a simplification and we could
On
define
distingue dans ces
5
systèmes
major
d'écoulement
systems.
le temps de
Therefore,
transfert
we in
qui ne
the
dépasse pas les
flow
55
systems,
ans,
there is the transfer
c'est-à-dire
time,
que sont
which does not
récentes,
exceed
et le
55
temps
years.
qui
That is
peut
very
dépasser
recent,
les milliers d'années.
new
Ça,
water.
c'est
And
le
in some
côté
cases, they can
plus, les
exceed
zones plus proches au
several
nord.
thousands
Ce sont
of
des
years.
paléos. Il
So
apparaît
those,
plus pertinent d'évaluer
and
l'impact
it
de la
seems
pression
more
anthropique
relevant
et du
to
changement de
assess the
recharge dans les
impact of
secteurs
anthropic
de l'Alto.
pressure and climate change in the
Pour
Alto
les perspectives,
region.
c'est où j'ouvre la discussion au
Perspectives,
sujet
well,
de
to
ce
open the
webinaire,
discussion concerning this
il est
webinar,
nécessaire de suivre l'évolution des
we
niveaux
have to
d'eau
follow
dans
the
les cours
evolution
d'eau
of
qui
water
traversent
levels in the
la
rivers,
nature
which
et de
go through
l'ébathymétrie des
the
cours d'eau qui
study
étudie
zone,
ou qui draine
and the
l'aquifer à base des
bathymetric
échanges.
surveys of the rivers
Et c'est où,
which feed or drain
faisant les
the
liens,
table. And
on peut
by doing
remarquer
the
que
link,
si on sait que
we
dans les
can
rivières
see
petites,
that
les rivières
if
jouent un
we
rôle
know
vraiment
what is in
important
the
dans
study
la
domain,
recharge.
rivers
Et
play a key role
ici, je vous
in the
présente dans cette
recharge.
carte
And here I'll show you
image,
in
un
this
nuage
map
de points qui a été
a
analysé ou
cloud
qui a
of
été étudié par des
dots,
étudiants du
a cluster of
master
dots studied by
en
students and masters,
microhydrogéologie qui est en
and
partenariat avec l'UNESCO et l'Université Mayor de San
done in
Andrés
partnership with
en Bolivie.
the university in
Dans ce
Bolivia.
cadre de travaux pratiques,
Within
des
this
travaux
framework
pratiques qui a
of
été dirigé
practical
par
work
Barbara et
done
par
by
Hervé,
Barbara
on
and
remarque que
Hervé, we can see that
il y a de plus en plus
there are more
d'extraction de
and more
carrières dans le secteur. Et ça va modifier
mining
la
of
surface
aggregates
des
in
domaines
the,
d'études,
and this
c'est-à-dire
will
ça va
modify
impacter,
the
ça va
surface
avoir un
of the
impact
domain
direct
of
sur la
study. This will
quantité,
have an
sur les
impact,
systèmes
direct impact
d'écoulement. Donc,
on
c'est
the
important
quantity
et
and
une
the
actualisation de la
flowing system.
géométrie du
So
domaine d'études
we
où
had to
on fait
update the geometry
l'inclusion
this,
ou inclut
and
les changements dans la
the
surface, comme je viens de
we
dire,
include the
et
change in
améliorer la
surfaces,
bathymétrie des cours d'eau.
and also we improve
En
the
termes de
bathymetry
qualité,
of
il
rivers.
faudra donc,
In
si
terms of
on fait
quality, we
cette
need to
extraction,
identify
on fait
the possible new sources of
il y aura
pollution.
des nouvelles sources de pollution. Ici, je vous présente une
This is a
photo
global
drone
view
prise par Hervé
or
Potet
taken by drone,
où
done
je
by
vous présente
Hervé,
la rivière qui
and you
trouve
can
ici
see
à
the
Balcocco.
river,
Et on
which
voit
is
que
in
tout le long de la
Balcocco,
rivière,
and you
il y a
can
des
see
activités d'extraction.
along the
Ça
river
va avoir un
there
impact direct
are a
sur,
mining, or there's
sur notre modèle en fait
mining
et
operations.
sur les cours
This
d'eau
will have impact the model
souterrains
and the flows
qu'on
on
peut
the underground
remarquer
water
ici
table
avec
flow.
cette
And we can see
photo
it here,
prise
for example,
par
with
Hervé
this
aussi, et
photo
où
taken
on
by
peut
Hervé as
remarquer
well. And we
qu'effectivement,
can
c'est la
see
surface qui
that
a
indeed
des
it
altérations
is
et
there
que
are alteration in the surface.
si on le voit avec une échelle,
And if we
on
look
peut
at this at
remarquer
the scale,
des
you can
incisions de
see
14 mètres de hauteur,
the
c'est-à-dire
about
que
14 meters of transition.
ici,
That is
dans cette
basically the
photo
incision
à
of
droite, on
14
peut
meters.
remarquer
In
où
the
la
photo
nappe
on the right hand
sort
side, you see
présentement.
the
Et on
groundwater
se rend
table
compte effectivement
flows
que
out,
toutes ces activités extractives
oozes
dans
out.
ces
So
rivières
all these
et
extraction
où on
activities
voit
along the
que
rivers,
les systèmes d'écoulement et les
we
temps de
can see
transfert sont
that
plus
clearly
courts, il y aura un impact
the
direct
flow system and
et
transfer
ça
time will
ouvre
be
la
shorter.
discussion
And
pour
this will have a direct impact, and it
des
opens the
améliorations
discussion
dans notre modèle et
for improvements in the model
pour collaboration à l'avenir. Donc, je vous
and for
remercie.
future
J'espère que
collaboration. Thank you for your
vous avez
attention.
tout compris, ce que les messages. Et si vous avez des questions, bon, voilà, je suis là.
And I'm happy to answer your questions. Thank you, Luis, for this your presentation. Thank you, Céline. Thank you to the team. You are kicking off the seminar on these major issues, especially the mining activities and the water resource. I don't know if you have questions yet. This is quite a spectacular case, actually, to do this. I mean, we can do this thanks to the work you've carried out upstream to understand and modelize this aquifer.
Moi, on attend les questions dans le chat, mais j'en ai une pour commencer.
I do have a question to start. We can see that there is an incision of up to 14 meters. What's the variation of the aquifer? Does the level of the table changes up to what level?
Bon de dire parce qu'en fait, ça c'est
Well,
après
that's
la modélisation.
well,
En fait,
it takes
ça
place
c'est
after the
pour
modeling,
savoir, pour
okay?
quantifier à l'avenir.
To
La réponse c'est
quantify the
qu'en fait,
future.
on ne sait pas. Et c'est pour ça que ça, c'est
So in
l'ouverture
fact, we
pour
don't know.
trouver
We don't know. This is why
apprécier de nouveaux travaux,
this is
de travaux.
opening to
Parce que,
new
en fait, notre
research,
modèle
new
a été
works,
fait avec
because
un
we
élémentaire
the model
30%.
was done
C'est-à-dire,
with the
ça, c'est
with
assez grossier parce
a
qu'on
system
était en
of
train
30
de
to 30.
travailler
It's
au
fairly
niveau
coarse
des bassins
because we
versants, à
wanted
l'échelle
to
des bassins
work
versants.
at the level of the catchment
Mais à ce
basin,
moment
at the
commence,
level of
on remarque qu'il y a des
catchment basin.
modifications
But
assez importantes dans la
what we know
surface.
that there
Et
are
ça serait
major
important
modifications
de
at the
faire une
surface,
actualisation de la
and it
surface
would be
de notre
interesting
modèle
to
pour une
update
amélioration.
the surface.
Pour rajouter à Louis, on a quelques piésos qu'on suit.
To add to Louis, we
on a
have
des sondes automatiques qui sont pas dans cette région-là. Et oui, on voit bien sûr le niveau fluctue, mais
of course, the level changes, but you know, as Louis says, you know, we can refine the model, and we'll have more detail on this zone.
les données
Actually,
terrain, pour l'instant,
yeah,
sont assez pauvres.
and the site data are limited.
Il y avait une question d'Emmanuel Mignot dans le chat là sur comment vous
There's a question on the chat. How did you calculate the dispersion in the panache of pollutant in the water? Well, it's a coupling between the transport of solutes and the transport of pollutant. Well, it's a conversion dispersion charter. Yeah,
Ouais, pour les culbus,
yeah,
c'est
it
Richards,
is the
couplé
for
avec
the
un
flow
modèle
is
de
Richards and coupled
modèle
with a
d'adversion dispersion, comme Céline vient de dire, mais où il n'y a pas
aspersion dispersion
dégradation
model, but there
de
is
la
no
substance
degradation as such of the substance that is
mentionné
injected, so we can actually
l'alto
trace
au
it.
tout début.
You mentioned El Alto at the beginning.
Du coup, c'est des enjeux très importants.
These are major aspects in terms of quantity and quality. So for the El Alto population and the adjacent populations.
Oui, en fait, c'est assez intéressant parce qu'on
It's interesting
a
because
remarqué
we
avec notre
noted
modèle
with the
que
model that
bien, il y a un impact direct
there is a
sur
direct
l'alto.
impact on the Alto,
Mais
but
je sais pas, vous
I
voyez
don't know if you
ici
can
les
see here the
foutaise. Donc,
cliff.
ce sont des
Those are
outfalls.
also
Donc,
outfalls.
c'est-à-dire
Therefore,
que l'eau qui sort
water that
de
comes from
l'aquifère,
the
elle va sortir
table
aussi, pas
will come
seulement
out here,
dans
not
les
just in the
rivières
river,
et
on
le
the
Lyon, mais
wetland, but
aussi à Chocaya et
in
Alto
Tucaya and
et parfois
Alto.
La Paz. Et on sait
And we know
qu'il y a
that
des
there are
communautés
communities
qui se localisent
which are located there
tout le long de
along
l'aquifère et qui,
the ridge,
des
and
cathédrales
they collect
d'eau
water.
qui prend l'eau souterraine
They
sans
draw
savoir
water
que
underground water
cette
table,
eau souterraine peut
not
avoir
knowing that
peut-être
there could
présenter des
be
problèmes
problem of
menacer
pollution,
la santé.
which could be
À l'avenir,
detrimental to health.
il faut quand même
We
essayer
will have to
d'essayer
do studies
mesures
to sample
d'échantillonner
the
ce
sector
secteur-là et évaluer la
and assess
qualité
the
de
quality
l'eau qui sort
of water coming out
de, par la falaise.
through the ridge.
Merci beaucoup,
Thank you,
Louis,
Luis, for your presentation.
cette première étude de cas. On va passer
Now, we'll move on to the second speaker,
donc Vikrant Jain,
Vikrant,
qui est de
Vikrant Jain from the Antinagar in India, who works on the Yamuna River, and especially in the crossing of New Delhi, when the river crosses Delhi, and he will explain the problem or discuss the issues of mining.
So yeah, very good evening, and thank you very much, Harvey, and for the invitation. So as mentioned, I will discuss about hydrogeomorphic impacts of anthropogenic stresses on a Yamuna River, which is a Himalayan river system. So I will talk about hydrology and morphology this part. And it's a group work where a team of our Nikita and Shalini are my PhD student, Professor R.D. Deshpande, NPRL, he worked on the isotope data, and Louis, Barbara, and Harvey, we are working as a team on the remote sensing based analysis part. And that's the introduction about the Yamuna River, which originates from the Himalayan part. And maybe I should point. So it originates from the Himalaya, the elevation of around 6,000 meters, and if travel to Delhi, which is around 400 kilometers downstream of the origin point. Total length is 1,376 kilometers. It's a large river system with a higher amount of volume and discharge data set. But then there are the anthropogenic stresses which are coming through these three aspects. One is the barrages. So one major barrage is there near the mountain front. That's called the Hatnikund barrage. Then there are two minor barrages are there within Delhi, and one moderate size barrage is there within the Himalayan part is there. So that was the first set of the stress. Second thing is that in between mountain front to Delhi and further downstream of Delhi, there is an extensive amount of silt sand mining is going on to support the infrastructure development around this part. And that is creating an impact on the river system. And third, when the river passes through the Delhi, which is around 22 kilometers stretch within Delhi, and if you talk about the NCR National Capital Region, which is around 50 kilometers of the stretch, then lots of water extraction, and then these differences are there. This rainfall is more on the Himalayan part, and then it is sporadic within these regions. So when it passes through the Delhi, we also see that in the last four decades, its population has increased from 5 million to 20 million people. And at present, the population is very close to the 30 million part. When we take about the NCR region as well, things are there. So the huge, so it's a story about the huge population load on a larger Himalayan river system and what will happen. The first impact is there on the hydrology. It's here in the plot. Y-axis, we have a peak discharge level, and then it is the downstream variation. In general, discharge increases downstream, but we can see that there is a decrease, and it's because of the Delhi regions. In this area, it is losing its water in the system, and hence there is a dip. And after that, once it receives the water from its tributaries, which are there on the southern side, it again regain and capture the part. So I will present the story of this small area around 400 kilometer stretch where river and then megacity interaction will take place. So first I will focus on water, what is happening, and then I will focus on geomorphology, that what is happening on those parts. So for the water, I have taken the approach to go in the field-based measurement, to go for hydraulic gradient and the stable isotope analysis to look for that what kind of interaction is taking place between groundwater and surface water, because that vertical connectivity is the key thing. There are lots of agriculture activities around the river, and that is generally known that a significant amount of water is extracted from the tube wells in the agricultural areas, and the river may be losing its water into the agricultural part, but there's no such data set before that studies. And then we have included the stable isotope data in a mixed model, and then quantify that relationship between groundwater and surface water. For this, the collection of data has been done in two periods, pre-monsoon and post-monsoon period. That's Nikita Karnataka, one of my PhD students, and that was her work, and she's collecting the data in this period. And this is the first set of results on the basis of the hydraulic gradient, where the groundwater level was measured along the river. So So we have measured the level of the river water as well as the groundwater at 1 kilometer and 2 kilometer on both left bank and right bank. So five data set were created along the river channel at the different site. And what we find out that there is no such very well defined pattern. There is a variability. Some of the places groundwater is higher and it is releasing water into the river. River is gaining, and some other places river is losing its water is there, which have been marked in those arrow parts. So in the red zones, river is losing the water, and blue zone, it is gaining the water is there. There is a variability in the system through the hydraulic part. The second data set, which is based on the stable isotope studies, and which shows that on the first axis, y-axis is the Del Latino data set, on the second is the Del Deuterium data set, and then the d-axis values are there. So we can see the blue line is the river water, and then all the green and yellow and the brown lines are the groundwater data set. On the left bank and right bank periods are there. If we look for the river water data set, it is showing that that the water get enriched into the heavier isotope. It means it is an impact of evaporation, and it is going, which is expected that when river moves from mountain front to the downstream, evaporation occurs, and then enrichment will be there. But all of a sudden, it is getting down, and then we are getting a very close interaction between groundwater and river water. And on the post-monsoon, it is the reverse things. And if we look for the groundwater value remains in the range of 0.8 to 0.10 in the both the condition. But here river water gets down. And what happens? It is the rainwater which is coming with this lighter isotope. It is added into the system, and the river water has the lower values are there. But again, very close to around this point, 350 kilometer distance, it is again mixing it very well in the part. And this is the area where the Delhi NCR region is stopped. Similar pattern is there in the deuterium part, evaporation rate, but again mixing, again this role of the fresh water, and again mixing with the groundwater is there. And the d-axis values are also indicating that the decrease, because this ratio is indicating there will be more impact on the Del Latino values. Hence, there is a decrease in the system. But again, after 350 kilometers, it's a very mixed signal is there. So the first hand data set suggests that the river water and groundwater is different up to 350 kilometer. But after that point, there is a mixing of the water is there, and there is a lot more interaction of these things. And this is the starting point of the Delhi NCR region. So then we have analyzed the mixing model part, and that's a simple model is taken. Delta 1 is the isotope values, and M1 and M2 are the fraction. M1 is during post-monsoon, it is the upstream discharge, and M2 is the pre-monsoon groundwater discharge is there. Based on these two equations, we can get the fraction of the river water contribution using this equation. And when we apply those equations at the different stations where the data set were collected, it provides a very interesting scenarios. In the first reach, very close to the mountain front, it is a losing stream. Then it's become a gaining, again become a losing stream in this part, then the gaining part, and ultimately in the Delhi NCR region, it's a major losing streams are there. And very close to the Delhi, at the initial part, the losing amount is 71%. It's a significant amount. Actually, there is a Delhi water board system is there. They extract the groundwater from the floodplain, and around 40% of the water supply to the Delhi region actually occurs from this area, and hence we are getting a significant amount of the river water loss to the groundwater surface is there. And initial condition in the mountain front is there because of the coarse gravel which are present there. And further downstream of Delhi, it again come back to the gaining streams are there. If we go for the causes for those reasons, it shows that at the upstream part, because of the gravel, it is losing water in the high porosity system. We find out a paleochannel in the midstream where it become a losing stream, and then ultimately it's a major losing stream in the NCR region is there. And that's why there is a condition that in general we will expect that water will increase downstream, but it is not increasing. If we plot the data set, then for the Delhi water actually coming here, which is downwards, whereas it should be there in the part. So it is losing because of the disconnectivity of the groundwater system is there. On the second part, then I will see that first is the hydrological part, how this losing characteristics and the other impacts then affect the geomorphology of the river system. For that, we have divided the river into four different stages, from mountain front, then midstream part, and then the Delhi NCR region is the third one, and then the downstream of the Delhi and NCR region. The dark color indicates the major barrages, and we will then analyze all these parts is there. These are the four different reaches which are present in the system. So the method was there that we applied a fluvial corridor toolbox, and then did the mapping, taking the data or the satellite images from 1984 to 21, then carried out the DGO-based analysis of the 500 meters, and then estimated the NDVA and the NDVA values so that we can identify the water features, and then the channel width in the system is there. Around few hundred images were used for the analysis, and if we see the water, there is a decrease in the hydrological system in the downstream because it is losing the connectivity of the water. So to analyze the geomorphic impact on the different stages, we have identified we have defined five different hypotheses. The hypotheses were very simple. It means that for the active channel width, if there is no impact, then we will not see any variation in the active channel width variation. But if a dam is there and its impact is there on the sediment transportation, we will see the lowering of the channel width, and the tributary will enhance that part. Second aspect is the sediment trapping is there because of the dam. We will see the further lowering in the active channel width. Third and fourth are related with the sediment mining. If the sediment mining is uneven, we will get that kind of scatter. Or if the sediment mining is more at a given area, we will get a larger peak in the system. So these five things will provide an approximation about the active channel width. And the fourth one is related to the discharge and water width variability, that how much water will affect. And these are the results which we got. So this is the data set of only one DGO. And then it is showing that the value of the active channel width, braiding index, vegetation channel, water width. And so all the data set here from 1989 to 2000 showed, which is showing the temporal plot. A scatter line has been set up, and the slope of this line has been used as a single plot, and that has been plotted here. So here the single line indicates say slope values are there. So all this, all the temporal data has been combined into single plot, and it has been plotted here. Then DGOs also been combined, 10 DGOs have been combined, and each plots indicate the 5 kilometer distance. And we can see a large amount of scatter in the active channel width. Braiding index, it is small, and again in the vegetation, and these parts are there. To understand this better, we have further then look for the data set at the different streams. And also, we also look for the river style approaches. So R1, R2 here is the different river style. And this part is the braided index, which used to change into a meandering system in the downstream part. So we look for the reaches and what are the major impacts are there. Here the red color is the, so these are the DGOs arranged from mountain front 0 to this part, from mountain front to downstream. And it shows that this is the location of the barrage, and downstream of barrages and upstream of barrages, we are not getting a significant impact. There is a drop in the water set, but there's a paper by Yadav et al. Which has suggested there is one of the dam in the Himalayan region, Biasi Dam is there. And it's because of that, this dam has been, and this drop is there. This dotted red line indicates the initiation point of the barrage, and we can see that no major change had happened when the barrage started functioning into the system. Hence, it shows that there is no major impact of the dam system is there. The changes started place after the building of the dam. Actually, that is the time period when the sediment mining has started into the system. And this is how it looks like, that if you look for the braiding channel, how it gets converted into a single channel system because of the excessive siltation, and then the loss of water at the mountain front is the reason for this. So we look from 2015 onwards, the braided system has been changed to the meandering system part. The sediment mining has further increased in the downstream, which is upstream of the Delhi NCR region, but downstream of the mountain front, where we can get large amount of scatter in the data set. And this scatter indicates that there is a randomness in the system. And that happens because sand mining distribution occurs at the different places at different time. Hence, we are getting all the scatters. There's no such pattern. And that is the part which is related with the extensive sand mining in the areas, in the region. Third aspect is the Delhi NCR region, where in the NCR region, these two brown color indicates the initiation of the Delhi regions, and this is the end point of the Delhi region. Blue color indicate the barrages, and they are showing that there is a decrease in the level of the active channel width, and that is expected because river is losing its water to the groundwater, and hence there is an extensive amount of losses there. For the downstream of Delhi, then we can see the recovery or the stability is there. Similar kind of features are there in the water width features are there. So river is losing water, and hence there is a morphology which has been affected this part. And last is the downstream of the Delhi NCR region. And in the downstream of the Delhi NCR region, you can see that the scatter has been reduced significantly. River is there in the recovery phase, and a little bit of the downstream decrease in the channel pattern is there, but the rate of the channel pattern decrease or channel width decrease has been decreased in the part, and there is lots of stability in the system. Water width is still a problem because this water extraction is still going on in the downstream of Delhi area, which is there, but geomorphic stability have been found out. So if we summarize all these things and we look for the river in the downstream of Delhi NCR, that looks like this, where Harvey has provided that image, that before 1989, it was a very well-defined meander with lots of meander scars and a very well-developed floodplain is there. But now it is losing its water, it is losing its sediment, river has incised into the system, and it has lots of connection with the floodplain. So it is still surviving, but it is not in a good health because of lots of stresses which are there in the system. So based on this, I will conclude my talk. And the main thing is that the Delhi NCR, with a population of around 30 million a year, has made a significant impact on the hydrological connectivity of a large Yamuna River system. And we find out there is a downstream decrease in the discharge, which also affected the sediment transport process, and sediment transport that further affected the channel morphological processes are there. There are the three major stresses are there for the morphology: barrages, sand mining, and Delhi NCR. But for the geomorphological aspect, gravel and sand mining is the major impact, which is not that visible, but based on the long-term, the remote sensing data set, we can see that the major impact on the geomorphic condition is by the gravel sand mining. And the last thing is to highlight the approach part, that we need a multidisciplinary approach to understand the anthropogenic impact on the river system. They are not very well observed in the single image data set. So what we have highlighted that based on the stable isotope analysis, we can analyze the loss of the water into the groundwater, and whole hydraulics has been disturbed. And once the hydrology has been disturbed, it has affected the morphology, and that can be very well analyzed using the time series remote sensing data sets are there. Thank you very much, and thanks for the team. And this is the Yamuna River near the Delhi NCR region, where all the different disturbances and activities are going on. Thank you.
Merci beaucoup, Vikrant, pour cette présentation. Alors, c'était un petit peu trop vite.
Thank you, Vikrant. It was difficult to follow for the interpreter, and
on sait qu'il est très fort. Et il a pu retranscrire tout ça. Alors, en attendant les questions...
While waiting for the questions on the chat, Vikrant, you showed the high complexity of the anthropic impact on the operation of the, especially going through Delhi, but not only. So, I have a question. Do you, I mean, the upstream reach before getting to Delhi, or in the plain, did you look for other pressure or stresses which could impact the river, or is it only the urban area that is the major that has the major impact?
Yeah, thanks for the question. Actually, yes, these three major impacts are related with the urban setup when we talk about the sand mining or the urbanization. But that major impact at the rural area is because of irrigation. And irrigation impact indirectly then affected by the groundwater surface water connection. So farmers are extracting the groundwater at a very high rate, and then river then replenish that groundwater into the system, into the floodplain. In this process, it is losing its water into river. So a few years back, when the river was a major gaining stream and that amount of discharge was much higher, but now the discharge has reduced because of this less amount of groundwater and surface water connectivity that is related with the irrigation aspect. So at the rural stage, it is the irrigation which is then providing the one of the stress.
Très bien, merci beaucoup. Donc, il y a
Thank
une
you.
question qui arrive de Léo
We do have a
Baptiste.
question. Maybe you can read it.
Donc, tu peux
Is
la
there a
lire
plan to
dans le chat,
restore
mais
over
demande
large
est-ce qu'il y
scales
a,
the complexity of the
des plans
channel?
pour restaurer
Yes.
Is there a kind of a
la rivière,
regional or
peut-être
national
à
renovation
large
program
échelle?
or restoration program?
Yes. Yes. Yes, there is a program. So there is a government agency called the National Mission Ganga Commission. And Yamuna River passes through the Delhi NCR region. So it remains in the limelight and media functions are there. I have only talked about the morphological condition, but the water quality is also one of the major issues are there. So there is a plan that, but that is still at the planning stage, I will say. Because those quantitative understandings are not yet there, that what is the loss of connectivity. These are just the recent work which is still not yet published, but how much water has been lost and how much water needs to be injected, what is the sediment transport characteristics are there. So these kind of quantitative parameter needs to be there and it will be included. But besides these things, as I understand it, the most of the stress is there to improve the water quality part. So at present, the focus is there on the water quality. The second aspect will come on the ecology part. That's where the hydro-geomorphology will be more important. And second question is about the Taj Mahal part. So Taj Mahal is further downstream. It is 200 kilometers downstream of Delhi. And by that time, river doesn't have that much of the water. So so there is no such major impact in terms of the erosion, but yeah, Taj Mahal is losing the beauty because the water is not of good quality and there is a very less amount of water. Again, it is the groundwater surface water connectivity that will provide the answers to the rehabilitation of the river system.
Merci beaucoup, Vikrant. Il faut qu'on passe à la suite. C'était très intéressant.
Thank you, Vikrant. We do have to move on. It was most interesting to travel to your country. And now I give the floor to Santiago Yépez, who associate professor at the university in Chile, who will talk about the mining pressure on rivers in and the morphological impact specific in the Biobío River, and the talking about the and the impact of
I would like to start my presentation say thank you to the ASDO Lyon and also the Collection de Lyon for support my internship in Lyon. I'm going to present the first result line of my PhD student Angela Contreras, with the support also of the Hervé Barbara as international advisor. The focus of the project of the Angela Contreras is try to establish relationship between in-channel mining pressure with geomorphological impact in Biobío River. We apply for this several techniques using time series of nanosatellite from Planet Labs, and also we combine this information using some observation using a UAV equipment coupled with optical and multispectral cameras. First, I will give some background of the study, then I will try to explain the methodology. Finally, I will try to show preliminary results about this study. Well, the context and the problem state of the this study is related to the extraction of aggregates in the Chilean rivers, and also is a huge, big problem in the rivers worldwide. In this slide, I show the context of the study. Sometimes river aggregate extraction it can cause important impact in potential geomorphological impact, for example, in relate to the erosion of the riverbed, change in the sedimentary bars, alteration in the plankton, and also can increase the flow risk in the river. We can see in the photo several activities related to the aggregate extraction in the Biobío River. We can see a huge sedimentation peaks and also a lot of extraction of voluminous sand and gravel in near to the mouth of the Biobío River that produce alteration in the riverbed. All this is combined sometimes with the increase of the activities of mining can create these sedimentation peaks that sometimes can occur accidents that, for example, in 2019, a worker drowned after failing into 20-meter pit next to the operation with the excavator. This is a very important impact in the operation in mining in this sector. Follow the context of the problem in the Biobío River. We have Chile is affected by the climate variability. In the last 2023, we was affected by two extreme events of flooding. In this slide, we can see the cartography. We can highlight 4 sections of the river, Laja River. We can see the impact of the flooding process in the urban areas. For example, in the other photo, we can see the site of the Laja waterfalls is a touristic place that increase the water decay and affecting the river channel, and also we have infrastructure near to the floodplain that was affected by the erosion of the water course. Well, the study area is located in the Biobío River basin. This river is very important because this affecting not only for the hydroelectric impact. We have a lot of enterprise, for example, the forestry industry, take a lot of water to the industrial process to convert wood to cellulose. And also we have the impact of the agriculture with the irrigation channels along the course of the river. Well, the Biobío River is characterized by a very steep slope that enhance the potential of the stream power. For this reason, we have a lot of dams and hydroelectric plant along the river. For example, the Ranco, Pangue, or Angostura are important hydroelectric plant that produce energy for the national electric system. In this feature, I would like to show some methodologies we are planning to implement in the future with a new project that we win in the call of Fondes Irregular. We're planning to use a battery of different equipment. For example, to try to use hydroacoustic equipment like ADCP. We try to combine this with UAV photogrammetry using drone. And also we implement some instrument like hyperspectral radiometers focused to the hydrologic application in order to implement this spectral profile to establish relationship with the suspended sediment concentration. We try to relate this to the sediment transport dynamic in the river. I'm going to pass to the next slide. And now I will present the research question and also the objective of the study. We has the research question. We wonder how can internal mining pressure be detected and monitored across different spatial scale. What geomorphological changes are associated with mining activity in the Biobío River? In order to understand this research question, we implement the objectives to link mining pressure with geomorphological change using a multi-scale remote sensing approach. Now, to achieve this objective, we propose a multi-scale methodological framework. We pass for different scale, from regional scale, intermediate scale, and local scale, using a different kind of data. For example, if you look the image in this slide, we can see we can try to use methodologies like the water occurrence model, a regional scale, using a time series of satellite images from Sentinel-2. We have almost five images per month in a 10 meter of spatial resolution. If we can use this kind of model to implement along the river to try to identify critical sites that it is possible to find mining operation. Sometimes illegal operation, sometimes industrial operation of aggregate extraction mining. And then we pass, when we identify these critical sites, we pass another scale using time series of nanosatellite from Planet Labs. These satellites are called super dove, 3 meters of spatial resolution. We have a temporal resolution of daily, and we can use this image to create the same methodology that apply using Sentinel-2. In this case, we use the methodology from Helling et al. In 2026. And we try to improve the resolution and the temporal resolution using this image. When we detect this site, we increase the scale using flights, using photogrammetry acquisition by drone. We use optical image in order to create orthomosite and also DTM, digital terrain model at different dates in order to apply a DOD approach. It's a subtraction of different digital terrain model in order to quantify the volume of erosion and sedimentation, and also try to monitoring this excavation, the sedimentation removal in this site. Well, the slide show the regional resort using Sentinel-2. I have the collaboration of Leo Heli and to processing this image in the sector of Laja River. We can see the evolution of the model of the water occurrence. The colors blue indicate that the water is permanent during almost of the year. But we can see the more interesting in this image, we can see the evolution of the extraction of sedimentation. Sorry, the evolution of the operations of mining of aggregate extraction in the river. We can see it also in 2023 related to the two stream flooding events. We can see the increase of the permanent water relate to the process flooding during this extreme event in this year. Sometimes this product at this scale is not enough to determine the impact of the mining operation. For this reason, we try to use another source of information. For example, in this case, we can see the sequences of images from Google Earth to see how evolve the mining operation. Sometimes the institution responsible for the control for the monitoring of this operation don't have the methodology, the personal, sometimes the technology to control, to monitoring in a proper way this operation. For example, we can see there is no possible to control the evolution of the extraction of sediment in the river. Sometimes this produce this modification in the channel product of this extraction of material in the river. We can see in the next slide a 3D perspective view using UAV data. This image provides a detailed view of the mining area. We try to highlight the active extraction, for example, with excavation areas and sediment removal. We can also observe the formation of sedimentation peak with high water and significant disturbance on the riverbed. We can see also the problem in the water quality. Sometimes if you see the detail of the image, we can see the operation can alter the water quality, and this problem has implication in ecological process downstream. Well, then we move to the intermediate scale. We use 10 series of planet scope with more spatial and temporal resolution, try to monitor mining activity focused in this critical size. I'm going to show some sequence using the extraction of the water mass using a spectral index like NDWI. It's the same approach to use the imaging spectrometry to try to highlight the signal or reflectant from the water. And the idea after that is try to create this kind of model to highlight the operation of the mining activities along the river. Another important result about this is that when we combine this information with 3D perspective image using drone, we can validate the patterns that we obtain using the water occurrence model. It's very important to calibrate the model when we use this kind of data. Another idea for this analysis is try to use different images from each month. The idea is using images from different months can be useful to identify areas where changes occur more frequently. If you observe this image, we could see these changes are associated with mining activity. For example, I don't know if you see this part of the river is more affected by the modification of the mining activity. Maybe we can use this information using the image from the quarter of the year, and we can use primary colors like red, green, and blue, and the combination yellow, cyan, and magenta to monitoring the change over the river. The white area is related to the area without modification during this period. And the idea is try to use the metric of the surface water to try to identify if the intensity of the activity of mining increase during this quarter of the year. Yeah, we are measuring the area of this color change to track how riverbed and floodplain shift over time. Well, Now we move to the local scale. We try to acquire a photogrammetry model using surface structure from motion, and also we are planning to use a LiDAR sensor in order to estimate the digital terrain model and also create orthomosaic in order to understand with more detail the change of the sediment bars and the modification in the platform of the river. We can also analyze local change such as erosion and sediment deposition. This level of detail is essential to understand the direct impact of the mining activities in the river. We start to acquire some orthomosaic, but we need to acquire more time series in order to apply the next level that is use the DOD analysis approach. DODs are then no different. It's simply the subtraction of the digital terrain model in order to quantify the geomorphic chain. The idea is try to establish or calculate the volume of erosion and sedimentation, and also try to understand the volume of extraction of the material in this sector. Some problem, we working very close with the institution responsible of the management of the water course, the DOH, the Dirección de Obras Hidráulicas. Sometimes they told they don't have personnel, they don't have method, they don't have technology to monitoring these activities. The idea with this project is try to offer this expertise in order to improve the control, the methodology to control and monitor the mining activities. Well, the last part, we try to integrate these different scales. We try to link in mining pressure with geomorphic chain. We establish relationship between the mining activity detecting by the time series of Sentinel-2 as a regional scale, and also using the planet image. We also try to establish, try to quantify the change detected by UAV equipment to establish to calculate the modification not only in the surface, but in the riverbed. Combine maybe this with some technologies related to acoustic technology like ADCP. ADCP is a remote sensing. Also, you can use the acoustic backcaster signal in order to establish relationship between this signal and the variation of the suspended sediment concentration. We can use this to establish relationship, and using the signal.
Santiago, il va falloir conclure.
Okay.
Le temps passe bien vite.
Okay. Using this information, we can estimate the suspended sediment concentration. When we use the primary velocity, we can establish the instantaneous sediment flow. The idea is try to collect information down upstream in the mining operation and downstream of the operation in order to see what happened in the water column and in the riverbed. Well, the main findings is apply multi-scale remote sensing, effectively detect mining activity, hyper-temporal imagery improves monitoring. When we use different scales of satellite images, UAV data allows precise quantification of erosion as a deposition, and this approach supports river management and impact assessment. We're planning in the future use also airborne LiDAR data to implement hydraulic simulation in order to simulate the flooding at different return periods using time series of discharge data. This is other. Well, that's it.
Merci beaucoup, Santiago. Tu es face à des extractions qui sont énormes également.
Thank you, Santiago. These are huge mining extraction. I mean, lots of
beaucoup d'enjeux.
a lot of challenges there. So time is running. So we do have questions in the chat. So please, you go to that, and we go to the next speaker. It's Gabriel Melun, who will talk about the alluvian gold mining in French Guiana. Is one of the managers was to manage this type of problem, but they're quite sensitive issues. Gabriel, you have the floor.
Bonjour à toutes et à tous, rebonjour.
So, well, happy to be with you. Gabriel Melun is my name. I deal with the hydromorphology and the management of sediment for scientific support of the French Office of Biodiversity, and therefore take advantage of this introduction to thank Céline, Barbara, and Hervé for this invitation to talk about a quite difficult topic where we've been invested for quite a while now on the OFB, that is the impact of the river sediment extraction on small rivers in French Guiana. So we've been working on this since 2017-18 on the impact and on the restoration impact, technical restoration, of course, with the State Department and the legal mining operations. The three steps in my presentation. First, remind you of the context and what is at stake in the mining activities in Guyana, the 4-point typology of the main environmental impacts of the mining activities, and then I'll discuss the monitoring methods for some of these impacts, which have been deployed with different partners. So first thing that I think is interesting is to mention is, of course, briefly, is to understand why there is gold in Guyana. Well, the geological events that shaped the Guyana shield, which goes well beyond the French Guyana, you know, they're not new, they're quite old, and a period between 2.2 and 2.2 billion years, and there's been several phases, major tectonic phases, complex tectonic phases, an opening phase and a closing phase of the ocean before the collision, which stage will lead to the erection of the mountain range and the Trans-Amazonian erogenesis, because there is this collision that West Africa and South America merge, and this is mainly composed of very old rocks, magma metamorphosed during the orogenesis phase, and there will be in all the rocks then okay, you can see here the belt of green rocks, which are east-west oriented, and with a belt above in the south, in the north, and in these green rocks belt, which come from volcano rocks following the closure of the former ocean. So to answer your first question about the origin of gold in Guyana, as you can see in the center, well, we realized that the gold mineralization associated with the two belts which took place. So today, the mountain range which caused that is no longer there, and the landscape has been leveled, eroded, even though some peaks, as you can see here, some peaks still remain in the landscape as a sort of those the three things to be remembered here on this. It covers 84,000 square kilometers. 95% is covered by wet tropical primary wet forest, and it is very high alteration with, we'll talk, there are a lot of leaching of soil, which results from heavy rains, leaching of soil, and lixivation. So soil are characterized by the very thin soils of, topsoils, only 10 centimeters, and very characterized by poor silica and nutrient contents. So once you understand how gold got there, well, how is it recovered, mined? So three main types of activities for gold. Well, for the mining, primary mining, that is, gold is extracted directly in the rocks, from the rocks. We talk about the Godino of the vein, gold quartz vein, and secondary mining activities, which is of interest to us, secondary or alluvial, fluvial, which is the alluvial sediments, the gold particle coming from the alteration of primary deposits, and this lasted, this alteration lasted for 10 millions of years. So it's a very long term. Secondary mining particulates are released, and then we're talking about millions of years, and then they end up being portion of they will deposit in the bottom of the valley at a depth which varies depending on the zones in Guyana, between 3 and 10 meters underground in the alluvial deposits. This is where gold is exploited in Guyana today. And there, high majority, 80% of gold is done in alluvial sediments. And this type of exploitation, we pay attention to. So historically speaking, gold, well, it has been mentioned since the major exploration in the 16th, 17th century, the El Dorado, it's only in 1855 that the presence of gold has been demonstrated in Guyana. So it was quite a recent. So the kicked a gold rush in a quite favorable context, which of course lasted until the beginning of First World War. It was, it was based on the very rudimentary tools, artisanal mining, the elements were built directly in the forest, including in very remote areas with no logistics. Following the First World War, the activity declined until the 70s, because the price of gold was low and there was not enough possible utilization of the gold resource. And then, as of the 70s, because of course, the mechanical systems were in, it was industrial mining operations, and therefore there was a significant growth of the production of gold in Guyana in the 80s and 90s. To give you an idea, the peak production was reached in 2001, legal production with about 4 tons of gold. In parallel, another thing, there is a regulatory framework which has been built progressively. This regulatory framework comes from this DOM, the Mining Orientation Departmental Program, and by the operation of derogatory mining permits. There were authorization of exploitation, AEX. It's a mining title. It's a derogatory mining. It's 80% of the zone exploited legally today are done within these AEX exploitation permits. This sets the rules of it sets the rules. There are a lot of regulations, of course, but except from very specific case, only rivers which are less than 7.5 meter wide can be exploited. Small ones, exploitations are done in closed circuits. We don't want to penalize the receiving environment. And the other thing that to be remembered, it is the phases, the stages of these operations. 3 steps, deforestation, so you can see on the right-hand side. Then second step, exploitation, where the underground will be exposed down to the gold. And the third step, very important, and this is essential, is the restoration and rehabilitation of the site, which is planned within the framework of the mining code in these current provisions. So creeks often are in the current, you see they're on the side of the major riverbed. We exploit the waterbed, it's a creek, it is often put in a jump to we want to make sure that there will not be flows, in the within zones, one of the problem is difference of water, lots of water in the low zone of the major riverbed in a tropical context where there are, especially during the rainy season. Now, what is at stake, basically, this is what's essential. Well, this is essential in Guyana. So they can be summarized in 10 points. These environmental stakes around the mining operations. First, what you have to have in mind is the amazing biodiversity, exceptional biodiversity of Guyana. 7,000 to 10,000 vegetal species, including 1,700 species of trees. In Guyana, there are about 100 and 200 species of trees per hectare versus about 10 per hectare in a European forest. So often there are as many trees in a 1 hectare of Guyana forest than all over Europe. So 1,000 species of vertebrate birds, 4,100 species of insects already documented, just the figures, which gives you the amazing biodiversity of the impacted environments. Biodiversity, land biodiversity, well, there's the aquatic biodiversity, which is very abundant and rich, 367 species of halieutic species, only in fresh water. There are only about 80 in France, so you see it's about 4 times higher, and there is a very high endemic dimension, especially in the Yamuna River, which alone has 300 species of fish or freshwater in the Yamuna basin. About 50 of them are endemic of this catchment basin. These are environments which are well preserved, and therefore we can say, well, because today, according to the last survey from the European Water Framework Directive, well, 70% they are in good condition, while in France it's only 10%. So the water bodies are well. So there are a little bit of sand in the machine. So there is a lack of knowledge of the hydrographic network of the biodiversity on macroinvertebrates. Consider that despite the hundreds of species already noted in Guyana, we consider that we know about 10% only of the species which are indeed present in the areas. Second aspect is the protection level of the environment. You can see this map here, which gives you an idea of the possibilities for exploitation found within the framework of wisdom. What you have to know that today, about 50% of the territory of Guyana could be used for gold mining. So what's in white, the non-exploitable zone, is the zone at the heart of the Amazon Park of Guyana, so where all legal exploitation is prohibited, which does not stop the illegal mining activities to take place. Third point, we got mining pressure, even more so in the last few months, with the increase of the increase of the gold, the price of gold, which is really rising. And things that, another thing is, of course, the impacts of such activities. We know them. I want to mention this typology of the impact of mining activities. Impact which already leave traces in the recent period of follow-up because of the European Framework Directive. If you look at the two maps at the top, you can see top left the legal, illegal gold mining activities. Well, they follow the rivers exactly, the green rocks belt. Well, if we transpose this in terms of ecological impact, you realize it complies also with the zone in gold mining without the zone which are highly degraded. Just a figure you can see depending on the condition. We realized that in fact in 12 years we've lost already 15 points of rivers and in good condition, and it violates the principle of non-degradation of the water frameworks or the water bodies. And last point, and I think we have to insist, there is a huge rush of illegal gold mining, especially because of the price of gold. Now, the impacts, well, rapidly. 4 points I'd like to insist on, of course. Deforestation. You see the graphic of the evolution of this deforestation in the last 25 years. So what you have to bear in mind is since 2012, we got about 1,000 hectares per year, which disappear because of legal and illegal activities. There was a major part of legal activities in deforestation, which led us to mention these legal activities which use a lot of space, and therefore they cause deforestation. And this reality tends to be reduced because of the number of illegal exploitation. It's about 50 between legal and illegal deforestation. It's 35,000 hectares of deforestation since the end of the 2080s or 2000, massive degradation of the soils, of the soil, and insist, of course, it's only 10 centimeters of topsoil, in the Amazon, and they're essential because they provide life and the support for development of these tropical forests. So the soil are digged at depths which vary to get the gold, usually between 3 to 7 meters. Sometimes, and you may see in some photos, up to 10 meters and more, where everything would be moved, and the topsoil is usually lost. So then after that, there is a lack of soil, very highly sensitive to erosion, lack of vegetation, and the washing and the leaching of the soil, and of course, the remobilization of the fine sediments which compose the lateritic area, and possibly mercury, which will cause a problem. I'll come back to this mercury. Third degradation, the degradation of the rivers and the creek. And again, 100 kilometers of river disappear every year. A third because of legal operation, 1/3 of it. So cumulated, it's about 4,000 kilometers of rivers in good condition often, which have been destroyed for about 20 years now. Usually with the diverting of the rivers, usually they're left in the when rehabilitation is not done correctly, it causes a lot of problem of incision, and they translate into at the same time, very fine material are being transported, and then be found, they will have cause pollution and the degradation of the main physical chemical parameters. I'm referring, of course, to the suspended solid, suspended solid values, the MES, but and again, SM, the suspended solid, and the turbidity as well, and the cumulative effect of lack of size and the accumulation of exposed surfaces, explosion of increase of temperature. That, just to give you an order of magnitude, creek in Guyana, usually temperature is between 24 and 26 degrees, quite high temperature. These are temperatures which can raise up by 10 degrees over 100 meters, So you can imagine that the life in a river at 24 degrees, when 100 meters later, it goes to 35, 37 degrees. Well, of course, it kills every, rivers become, abiotic in such conditions.
Et puis la dernière conséquence, c'est bien sûr.
Last one is contamination, of course. Pollution contamination was assessed in 2015. That's, it's a bit, it's very difficult to, but in 2015, the ONF considered that about 10,000 kilometers of rivers had been degraded because of the alluvial degradation. It's underestimated, because it's an underestimation. It corresponds to 10% of the non-hydrographic network of Guyana. Why? Because it relied on turbidity measurements, and turbidity measurements, you can see them here on the photos, on the rivers which are visible, but most of the hydrographic network in Guyana is not visible, and it is under cover. It is under the canopy, and you cannot detect it. There is a major issue also of mercury pollution. Mercury, well, of course, it varies. There's natural origin with the, the rich mercury fund. I mean, usually it is trapped in the soil, but mainly mercury, anthropic mercury, which is different sources. It goes mainly for the amalgamation of gold, the historically, legal, but to the illegal operation, use a lot of mercury to amalgamate gold and to recuperate in the, usually done by gravitation. Deforestation leads to release of high quantity of mercury, which was trapped in the vegetation. And now there is the remobilization of natural stocks of mercury, which could be present in the former exploited zones. Gabriel, you need to conclude. All forms of mercury are toxic, but mercury vapors and organic form and methyl mercury can, can cause this is really the illegal gold mining, but maybe it is a environmental disaster. 6 to 8, 2000 coming from illegal miners. 500 sites, monitored by the, and they extract between 3.5 and 7 tons of gold, more than the legal activities. And then, of course, they cause major damage and cause the presence of mercury. And the monitoring of activities, well, mainly the impact associated with deforestation and destruction of rivers. And there's the Observatory of Mining Activity in Guyana, and we use a methodology with simple daily detection. We do photo interpretation in Sentinel-2 images to detect the patches you see on the right-hand side, and then automatic process with validation on site, either during control or to different using aerial systems. It's an interesting methodology. We can process images at the weekly time intervals, and we can monitor the activities with good report of activities. You see these maps, which are time maps of extension of zone impacted by the activities.
Voilà, j'ai fini. Excusez-moi pour le...
I'm done. Sorry, I was a bit long, says the speaker.
Merci beaucoup, Gabriel. C'était vraiment très intéressant. Nous donner
Thank you. Most interesting to give us
revers de la médaille d'autres aspects
another
de cette
vision
urbanisation
of another
généralisée
aspect of
via
this
l'exploitation
of
minière.
the
Et
problem
tu avais une
of
question dans le chat,
coal mining. You got
donc
the
tu peux
question in
aller
the chat,
regarder. Et
so
on va
you're going
passer,
to answer them. So
avant,
we move
merci,
on
on va
now
passer à la dernière
we move on
présentation
to the
pour
last
laisser un petit peu
presentation
les discussions
to give a
communes
bit of
après.
time
Donc,
of discussion.
je passe la parole à Baptiste Potet, qui est chargé de mission au
Baptiste
sein de
Potet, who is
Epidor, c'est
mission
l'établissement
officer
public
in
territorial du
Epilog,
bassin de
which
la
is
Dordogne.
the
Et qui va
Dordogne
nous parler
River
d'une
Catchment
stratégie
Basin
pour avoir les
Authority.
solutions
And we'll talk about
apportées à ces
strategy for
problématiques,
the
des stratégies de restauration
Morphosedimentary
morphosédimentaire de la
restoration,
rivière Dordogne,
rehabilitation of
en
the
lien avec
Dordogne
le
River.
projet Life Loire en Dordogne. Vas-y, Baptiste.
With the within the LIFE project.
Pour l'invitation. Donc, je conclus ce webinaire pour vous présenter un retour d'expérience
So
sur la rivière
I
Dordogne.
will talk about the
Et
experience on the
particulièrement,
Dordogne
dans le
River, and
cadre du projet
especially
Life Rivière
within the
Dordogne,
framework of the
où on
LIFE Rivière
souhaite
Dordogne project,
aboutir à une
where
stratégie
we
de
want to
restauration
define a
morphosédimentaire à
restoration
l'échelle
strategy,
de l'axe de la rivière
morphosedimentary
Dordogne.
restoration in the river.
Donc tout d'abord, quelques présentations sur le
A
contexte
couple of
du bassin de la rivière
the
Dordogne
context
et
of the
aussi
Dordogne River
du
basin
rôle
and
fondamental de
the
l'établissement
fundamental
public
role of
pour lequel je
the
travaille. Donc
organization I work
public
for.
interdépartemental
It is an
qui travaille à l'échelle du
interdepartmental
bassin de la
public
rivière Dordogne
institution
pour une
working at the
gestion
scale of the river
harmonieuse de
basin
l'eau
for
et des
better
milieux
management of
naturels
water and of the
afférents
natural
donc à ce
environments
milieu aquatique.
associated
Donc
with
depuis
this
son
aquatic
essence en
environment.
1991,
It was created in
Epidor travaille
1991.
avec les
Epidor
collectivités et
works
les partenaires
with local authorities and
sur l'ensemble de
partners
ces territoires
for in all
et en
these
particulier
areas,
sur l'axe
and especially
Rivière-Dordogne,
in
une
the
rivière qui fait 475 km
Dordogne
de long
River is
sur un bassin qui
475
fait lui
kilometers long,
25 000
and the
km².
catchment basin
Les
covers 25
activités
tons square
sur ce
kilometer.
bassin sont
Major
multiples.
activities on
Sur
the
le haut
basin,
du bassin,
but they are at
sur les
the
contreforts du
upstream
Massif
part.
central,
In
il y a de
the
nombreuses
mountain, there are
activités
many
liées au barrage, donc à la production
dams,
hydroélectrique,
hydro
dans laquelle ce bassin est la troisième tranche,
power
la
production.
troisième
So
structure hydroélectrique française.
this is the third largest in France, and there, in the last century there were massive extraction of pebbles or gravels, and especially on the middle part of the river. I'll come back, and there are also environmental aspects such as the. Since 2012, we considered as a biosphere reserve, and there are several Natura 2000 sites, and especially along the water corridors. And we also have more than 8 species of migrating fishes still present in the catchment basin. And all this, of course, lead to usages which will depend, of course, the quality of the aquatic environment. So high touristic activity, leisure, bathing, and also professional and leisure activity around fishing, and also should be noted aspect related to drinking water.
Donc Epidor, riche de ses 30 ans, a aussi
Epidor, has established hydro-sedimentary diagnostic, and there was a PhD done in 2001 which established a diagnostic hydro-sedimentary diagnostic on the median river downstream from the major dams in the Dordogne, the Périgord, and the Massif Central. So first aspect of the hydrology is modified because of the hydroelectric activities. So on the right-hand figure, you can see the advent of major dams on the river, and concentrated between the 1930s and 1950s, and therefore this has an impact, major impact on first seasonal. There is seasonal storage, about 1 billion cubic meter on the 6 dams. There is a net reduction of the frequency and the intensity of the floods. We don't have any morphogenic floods like at 50 and 20 years. And finally, a high variation of flow rates because of the operation of the waters in the reservoirs. You see, variations can be several hundred cubic meter depending in several days. So other conclusion, there is a blockage of the sediment transfer because of the dams and because of the extraction pits for aggregates. We consider that this blockage is about 4,500 cubic meter per year. So it's a creation of about 300,000 cubic meter deficit of sediment, in the basin. So concerning the extraction activity, mining activity, which consists between the Benin 30 till prohibition of extraction activities in 1980, well, extraction were about 9 million cubic meter of aggregate extracted from the minor beds in the median Dordogne. And today we find you see the zones with pits. Some of the pits can be up to 10 meters deep, and they're still trap sediments, and they do impact the sediment transit in the median part of the river. Sorry. Third point is the modification of the river dynamics because of the disturbances caused by dams and extractions, and also at the end of the 70s, we see local will to protect the banks, which are impacted by the incision which is being observed. So, and the shores, and as of after the 70s and in the high Dordogne, well,
se voile avec notamment l'avènement de
we
protection de berges par enrochement
they were
sur une rivière de 32 km
branch, they were bank protection about over 32 kilometers. That is about 50% of the Lot River. So the loss of total surface of small islands, incisions and vegetation, are more developed, grow more on the little islands. So there's cumulative loss of surface and reduction of the active strip of about 30 meter, reduction about 30 meter of the active profile. And then this will lead also to the lowering of the riverbed because of since the dams and the extraction activities, and we were able to quantify it's about from 1.4 to 1.2 to 2 centimeters per year, and in the middle part it's about up to 1.4 meter, and some zone could be 4 meter of incision at the location of the former extraction activities. So what's the impact of natural environments? Well, we were able to study this through documents, Natura 2000 and documents from management plans. We were able to evidence that the river before the activities was at a high, rich biodiversity and had diverse habitats and protected species. And following the dysfunctions, morphological dysfunctioning, we see a progressive disconnection of the river lateral elements, and you see, and modification of the habitats. For example, for a species of the Atlantic salmon, the Salmonella, which reproduce spawns and downstream from the dam, there's a degradation of the spawning zones. So the 50% of the spawning area have been degraded. And therefore, to explain this, to add to this pressure, there is a change of utilization of the immediate banks of the river and the fragilization of the environments because of global warming and the rapid increase of water temperature. And finally, in the what we see, we study risk on some ecosystemic indexes and the capacity of in the eporic zones, in the eporic exchanges. So Epidor applied to we applied for life candidacy. So this is the financial instrument for the environment of the European Commission to do ambitious project in the environment. So we applied in the project was selected in 2020 for objectives. First, to improve the ecological condition of the river over 280 kilometers of the river, down from the dams, downstream from the dams, upstream from the exchange with the estuary. And the objectives were targeted 5 habitats or community and 3 species. Then second objective is to reinforce the policies and the management policies and the devices, revision, creation of new protection for decree for the biotopes. So develop the awareness raising, especially the players of the valley. So there are several people develop methods and know-how which will be reused at the end of the life project, and especially land use strategy to have aqualand, and of course then a sedimentary strategy plan to continue the restoration actions and to try to compensate this sediment deficit in the long term. So this is funding from by Europe and the water agency Adour-Garonne, European Union and Agence Adour Europe. So what are the main solutions for this project? First, the morphoecologic rehabilitation works. There are zones where we want to act, for example, former aggregate mining zones, which can be restored. They're close to the river. They're sites with large surfaces, several tens of hectares, and often they are left abandoned or in zones which are highly degraded with very few species of interest. So in this project, we worked on the 3 former mining zones. So we got about 80,000 cubic meters of sediment, which have been re-injected into the river. So another focus on another restoration site in Maisonneuve site at the confluence with the Béziers River. So the intervention, first, we departitioned the river, which had been partitioned through. So we want to restore the zone and terraces at the different elevations to allow different flows and restore varied habitats. And also we want to do extension of hydraulic branching or reconnections with the features which are often disconnected. And we re-inject all the materials which are dropped. So we do excavation and the refill and we and in some zone we also seed, or we will restore vegetation. Results are quite obvious, you see. you can see a high diversity of species and environments, which you see this a bird species, for example. Also, we want to maintain farming activities, so the production of fodder, which can be significant. We improve some services such as the nitrogen removal, and of course, we also do awareness raising to the population. So there are morpho-ecological restoration, hydraulic restoration, hydraulic annex restorations. We re-inject sediments in you see, for example, this has been done in 2 domains, and also we wanted to departition the channel and remove the rock banks in zones. So we were able to clear about 1 kilometer of rock banks, and therefore this release about 30,000 cubic meter of sediment should have been remobilized, you see. And you see the banks which have been modified. So these are simple. We remove the rocks and we re-inject this in the river. And again, the results are amazing. And for example, you see the little bird, swallow, protected bird, which now come to this environment. So last work, restoration of spawning areas for the Atlantic salmon or the gardalos, and therefore we have 2 types: the re-injection specific, to have the activities, or lately we've experimenting being passive solution. We inject material in zones where we know there is it can be remobilized by the river. So we re-injected about 2,000 cubic meters of sediments in a zone which is strategic for the spawning of salmon. Now we have a long-term strategy. Now we are reinforcing, and we'd like to implement between before the end of the LIFE project to change the evolution of the river and find to restore the functionalities of and mainly the ecosystemic service. So we have the return of experience of the LIFE project and several experimented techniques. We try to have an action framework with responsibilities, partners, fundings, of course. And finally, one of the objectives of the strategy is to improve the social appropriation and to find the source of interest through the services provided, ecosystemic benefits, and to the socioeconomic benefits of such services. So let me finish with this slide as a summary and perspective. So let's give us the look at the result of the work done so the hydromorphologic dysfunctioning remain, of course, despite the work we've done. Through LIFE, with this ambitious work, we've been able to re-inject almost 180,000 cubic meter of material away from the deficit, which is a minimum, but 800,000 cubic meter and minima. So we still have a lot of work to do to achieve this volume, to get the volume. So this return of experience, is highly valorized. We try to improve the practice in terms of managers and new partners. So we also use new experience in the management of this domain with to have better knowledge on the habitat and to understand the work and the management in general. And we want to continue the rehabilitation and restoration actions of the river systems and the alluvial systems to maintain the ecosystemic services, because we are convinced that in the future to convince partners, technical and public partners, well, we have to ensure that beyond the objectives of this, we will achieve the benefits and services. This is the perspective. Thank you.
Merci beaucoup, Baptiste. On est très content que tu aies pu intervenir pour nous présenter des belles choses.
Thank you, Baptiste. We're happy that we've been able to take the floor to show us what is done at the Dordogne. Very ambitious question in the chat, so for the other speakers. So we got 5 minutes. 5 minutes. I can see that Matt opened this camera. Matt is one of the pioneer of the river geomorphology, who studied aggregate extraction and their impacts. Matt, you have the floor.
Thanks, Hervé. A wonderful set of talks. I have to say, a little depressing, but that's what goes with this topic. The first 4 talks documenting impacts in the global south, and where we have relatively little control, and we still see these activities in full force. We can think, though, on temporal scale, that as illustrated by Baptiste's talk, we had the same kind of large-scale impacts on rivers in Europe and North America and elsewhere, but we have belatedly tried to stop the extent of the impacts and also to try some restoration. This is really a case of the tragedy of the commons, where you have a lucrative private business whose costs are borne by society and the environment at large. It's partly a question of scale. There are many places where you have small artisanal mining on a relatively small scale compared to the flux of sediment in the river system, and the impacts can be negligible. But when we scale up to industrial mining, either for aggregate or for gold, then we see the impacts can be absolutely staggering. We can blame illegal mining in some cases, but not all. I think Gabriel's talk illustrated that, when you look at most of the split between legal and illegal, it's roughly half and half. So there's still a lot of legal mining, and even if we try to come up with ways to constrain, as long as the volumes are still so large, we will have impacts. So the fact that the miner has a piece of paper that gives him a permit to extract these large volumes doesn't mean that the impacts will not be there. And what can we do? Well, certainly public education and trying to understand and get our management to change, our regulations to change. And in order to do that, we have to improve public understanding and the understanding by the decision makers. Yet, even if we're successful in doing that, the decision makers will still be under tremendous pressure to give permits to miners because of the very strong economic benefits from these. Short-term economic benefits, but very strong nonetheless. So it's partly on us to do a better job of conveying how the rivers work and how this kind of extraction negatively affects the rivers. But beyond that, we need to recognize that there are these economic forces, and if we can spend more effort in finding alternatives to aggregate for construction, or river-borne aggregate for construction. And then for gold mining, I don't have a solution for that. But thank you very much. These were really, really thought-provoking talks and provided a very comprehensive picture of the kinds of impacts that we see throughout the world and from which our rivers in France and the US, other places, are starting to recover.
Super, merci beaucoup Matt pour ces conclusions.